In this video, we are going to discuss some more example for Unit 1 MCQ TOC. So here, the first question is, which of the following is not a regular? So not a regular in the sense we cannot construct an NFA or DFA for it. So when you are able to construct an NFA, DFA, then we can call those kind of language as a regular language. Okay, so the first example is the set of strings that is made up of a power a like a comma b the whole star. It means that combination of a and b with an even number of b's. So input is made up of a and b combination, and here we are going to focus on even number of b's. So one short way of finding it is you can have two states. Okay, so when you have a B in an input, we can have a transition from one state to other state. When there is another B in the input, we can have a trans back of it. We can traverse back to the previous state. So this goes in a looping state. So what happened, like when a transition is there in this state, it means that it takes even number of B's. So here for the state, it takes odd number of B's. Okay, you can have this as a starting state. So for the first B, it goes to the state, and second B, it comes back. Third, fourth, fifth, sixth. So in an input, like you can have, it is in a combination of A and B. So we are not bothered about the A. So whatever A comes, we will stay in the state where we are. But whenever we have a B, we have a transition. So for all odd number of B's, the transition will be there in the state, and for all even number of B's, the transition will be in the state. Okay, so this is a DFA, right? So we can construct a DFA that accepts the string with an even number of B's. So this is allowed. So when you are able to construct an NFA or DFA, we can call this as a regular language. And what the question is, we're going to find which of the following are not regular. Okay, so this option doesn't come. Okay, it won't suit. So we'll take the next example. Set of strings in A, B, C the whole star where there is no C anywhere to the left of A. To the left of A. The input is made up of the combination of A, B, B, A or A, B, C and all. A, B, C the whole star. And our actual constraint is when there is a C, to the left of C, you should not have any A. Okay, so what we have to focus on, we have to check whether you have a to the left of A, correct? So we should not have no C anywhere to left of A. So it is a wrong one. So when there is an A, to the left of A, we should not have any C. So that is the constraint. Okay, so what we can do now, like we cannot move back. Okay, to traverse to the left, it is hard, but we can traverse to the right side in your input. Okay, so we can take the input as it is, A, B, B, A, C or something. So whenever you have an input as C, okay, so it actually means there is no C anywhere to left of A. Okay, so we should not have any A after that. So we should not have, whenever a C comes, it should not followed by any A. So that is the meaning, right? So when to the A, to the left of A, you should not have any C. It means that to the right of C, you should not have any A too. Okay, so we can have a transition like this. So one state, whenever there is an input C, C is there in the input, it makes a transition. So after moving to the state, you should not have any A transition. If there is any A transition, we can go to a non-final state, or the remaining states will act as a final state. It goes in the complement category. Okay, so here you can have a self loop. When your input is A or B, you're not bothered about it. But whenever a C comes, it should not followed by any A's. Okay, so here also you can have either B or C. It is not an issue, but whenever an A comes, it goes to a non-final state. And here we can make a self loop as A, B, C. Okay, so for this example also, we can construct a finite automata, NFA or DFA. So this is also not a correct option. So this is also a regular language. And coming to the next option. So next option is the set of string. It is made up of 0, 1 and it is encoded in a binary. So the input that we have taken is a binary input, and an integer w is multiples of 2. So whatever we take, it should be a multiples of 2, like 2, 4, 6, 8 in all. And we have to check whether the input is, the taken binary input is it does a multiples of 2 or not. So one simple constraint is whenever whenever an even number is expressed, its end value is 0. For 2 it is 10, for 4 it is 100, whatever it is, the end value. If the end value is 0, then it is an even number. Okay, so then we can say that it is a multiples of 2. So for this, how can we draw an NFA or DFA? A simple one. I can draw an NFA for it. For input is either 0 or 1, it stays in the state. When the input end with 0, it goes to a final state. Okay, so whenever the input end with 0, we can move to the transition to a final state. So this is also a regular language. Okay, so all the set of language, there is a possibility of drawing an NFA or DFA for it. Then we can call all the three languages as a regular. So there is no option given for a non-regular language over here. So we have to choose option D, none of the mentioned. Okay. So now coming to the next question. Next question is, if L is a DFA regular, okay, DFA regular in the sense it is a regular language. For any regular language, we can construct a DFA for it. Then L dash is, okay, so L dash is the complement or the inverse. Whatever language is accepted by L will be rejected by L dash, and the reverse of it. Okay, so one way is like we can make all the final states of the given DFA as non-final and all the non-final as final. Okay, then it works perfect. Okay, so we can, like here L is a DFA regular, then L dash is also a DFA regular. Okay, so it is also a DFA regular. The reason is we can, when you make all the final state as non-final and non-final as final, then surely it also exactly accepts all the inputs. Okay, so it is similar to a DFA. That is the complement. So it is not regular, no. It is not finite, no. It's none of the mention also, no. It is also a DFA regular. Now coming to the last question, the finite state machine are not able to recognize palindrome. What is palindrome? Palindrome is a string, like it means that input is made up of any combinations AB, AB, AB and all. Okay, so a string and its reverse. If the string and its reverse are same, then we can say that it is a palindrome string. And we cannot construct a finite automata for accepting the palindrome string. The reason is we don't know exactly what is the middle element. We don't know exactly what is the middle element and where we have the middle element. And even if we know the middle element, we cannot compare the upper half with the lower half. Since we don't have any memory unit, we cannot compare this. So finite automata cannot deterministically find the midpoint. Yeah, this is also correct. And finite automata cannot remember arbitrary length of data. Yeah, we don't have any external memory unit. So this is also correct. Even if the midpoint is known, we cannot find whether the second half matches the first half. Okay, so here we have to compare the second half with the first half to check whether it is same or not. Okay, so all the three options are satisfied. The reason, satisfying reason that we cannot have a finite, we cannot construct finite automata for recognizing a palindrome. Okay, so we can choose the option as all of the mentioned. Thank you. Thank you.